My name is Sarah Broninger, and I want to talk to you about math. Now, I love math, but many kids hate math and have great losses at math, which leads you to think if they're working hard to make sure they understand all the words, if they're working hard to do all the demonstrations, if they take care to make sure that they do all the correct gradients in the correct sequence, why would they hate math? The answer is not that they're not applying themselves. The answer is there's missing data in the math curriculums themselves. There are missing words, missing definitions, missing concepts, and a huge amount of missing demonstrations. And I'm going to show you an example of this. I'm going to keep it to the 4th grade level. Firstly, because it is so key and it underlies so much more math. And secondly, I don't want to lose anyone, so I'm going to start with something so simple that you will be amazed that this is omitted in books. The very first omitted definition is in 3rd grade, and it has to do with a number. 2 things plus 3 things make 5 things. That's simple. This is a number of things. This is a number of things. And this is a number of things. Once we hit 3rd grade, we get this. 2 things times 3 things is 6 things. What does that mean? It doesn't actually make sense. This is 2 things, and this is 6 things. But this is not 3 things, and that is the omitted definition. This is 3 times. It's an action. So a number can be a thing, or a number can be an action of how often something happens. This means someone's waving their magic wand 3 times to make this happen 3 times. So a number can be a thing, and a number can be an idea of how often something happens. That's one of the first missing definitions. Where this comes into play is in division and in fractions. Most kids progress through 3rd grade fine, 4th grade fine, they get to 5th grade and they die. Because at 5th grade or in 4th grade, depending on your curriculum, they start getting division word problems and they hate them. They'll do division all day long. Give me pages of division, I'll do it. If your times table's okay, they'll do division. But keep away from those horrible division word problems. And that is because of this skipped concept. There are 2 ways, both valid, of thinking of a division. You can think of it in what I call split. And this is what most everyone demonstrates. 6 divided by 2 is 3. I have 6 things. I split them into 2 pieces. I have 3 in each piece. Everyone's happy with that. This is the one that's often not taught. Fit. I have 6 things. I want to see how many times 2 goes into it. It goes in 3 times. So now I've got 6 things. How many times does 2 fit in my 6 things? It fits in 3 times. This is an idea of how often. So you get word problems. Oh, I should draw that. 1, 2, 3. Here is 2 fitting in once. Here is 2 fitting in a 3rd time. 2nd time, here is 2 fitting in a 3rd time. So you get word problems that are split. Kids have no problem with that. I have 6 candy bars. I have 2 kids. Each kid gets 3 candy bars. Everyone's happy. But then you get word problems that are fit, and everyone's lost. I have 6 apples. I eat 2 apples a day. How many days before I run out of apples? Well, I'm seeing how many times this fits in there. It fits in 3 times. This is an idea of how often it happens. Where this gets tricky is fractions, which is the next big hurdle where people get lost. I'm sure you've all heard word problems like this. I have $4 million. It costs $500,000 to build a house. How many houses can I build? That's a fit problem. And it looks like this. So how on earth did you take a number like 4 divide it by half and get a huge number like 8. That's very hard to demonstrate if you have no idea of fit. Fit means I have 4, and I want to know how many halves fit into it. Eight of them. This is an idea of how often. It is not a number of things. So do you see how basic and fundamental and how it underlines so much math to have the idea that this is an idea of how often. This is a thing. This is a thing. And this thing fits in this thing 8 times. This is what I mean when I say that the demonstrations of math, the sequence of math, and the words of math are incomplete in our current curriculums. I've made a study of math books written in the early 1900s. They're wonderful. They don't skip all of these gradients. They explain the mechanisms, and they approach math from the viewpoint that it needs to be 90% understanding and 10% memorization. The way math is taught now, there's almost no understanding, and it's all memorization. You get to algebra, and it's all memorization, and it's like a sliver of understanding. And algebra is all fractions, so fractions have to be understood. I'm going to read you something from a book called The Deliberate Dumbing Down of America by Charlotte Thompson Iserbyt. A wonderful book, very upsetting book to read because she details the deliberate steps that have been taken to ruin the education in our country. But it is excellent data. This is an excerpt. A deliberate math dumb-down was seriously discussed in 1928. A teacher named A.O. Nelson, John Dewey, Edward Thorndike, who conducted early behavior psychology experiments with chickens, and other Council on Foreign Relations members attended a Progressive Education Association meeting in 1928, and A.O. Nelson was informed that the purpose of new math was to dumb down students. This is what he wrote. This is the words of this man. I know from personal experience what I'm talking about. In December 1928, I was asked to talk at the American Association for the Advancement of Science. On December 27th, naive and inexperienced, I agreed. I had done some special work in teaching functional physics in high school. That was my topic. The next day, the 28th, Dr. Ziegler asked me if I would attend a special educational meeting in his room after the AAAS meeting. We met from 10 p.m. until after 2:30 a.m. The sole work of the group was to destroy our schools. We spent 1 hour and 45 minutes discussing the so-called modern math. At one point, I objected because there was too much memory work, and math is reasoning, not memory. Dr. Ziegler turned to me and said, Nelson, wake up. That is what we want. A math that pupils cannot apply to life situations when they get out of school. That math was not introduced until much later, as those present thought it was too radical a change. A milder course by Dr. Breckner was substituted, but it was also worthless as far as understanding math was concerned. The radical change was introduced in 1952, and it is the one we are using now. So if pupils come out of high school not knowing any math, don't blame them. The results are supposed to be worthless. A little hard-hitting. So when you have a student feeling there's something wrong with them because they've worked so hard to make sure that they understood all the words, and they've worked so hard to demonstrate the concepts, and they've made sure that they didn't skip any gradients, the problem is not the student. The problem is the curriculum. And we now have 3 generations who have been taught with this new math. So the teachers don't know what's missing. So if you want to give your kids math with a complete curriculum, go to very old math books. Ask your great-grandparents. Thank you.